Welcome to the lecture. In this lecture, we are going to discuss about the serial communication. So let us discuss what is the serial communication. We know we have two types of communication, that is parallel communication and serial communication. So let us have a glance here. You can see we have two devices like two device which acts as transmitter and receiver. And you can see the dots here is the data transferring from a device to another device. So in serial communication, you can see the data will be transmitted bit after the bit, that is one after the one other in the same line, where in parallel communication the bit will be transmitted at the same time in a different channels or different mode of selection lines. So we have two basic types of communication, which is nothing but the serial communication and also the parallel communication. So let us discuss the serial communication. So we know that data transmit will be taken by bit, and we use the protocol like UART, RS-232, SPI, I2C nowadays, right? So serial communication is a method of transmitting data from one bit at a time over a single communication channel or wire or wireless or whatever may be, and it is widely used in electronics for its mainly of simplicity and low cost, especially in embedded systems like microcontrollers and for the computer peripherals. And key concepts are we have two types of system, that is asynchronous system and synchronous system. So asynchronous system means there will be no clock signal, so we have to give a start bit and a stop bit to notify the particular data transmitter. Whereas in the synchronous we have a clock signal, so that we can acknowledge through the clock signal whenever the data is ready to transmit. So here in synchronous you can see you have UART, that is RS-232, and in synchronous we have SPI I2C. Here you can see UART basics we are going to discuss. UART stands for Universal Asynchronous Receiver and Transmitter. So wherever we have an serial communication, we can see transmitter receiver will be there. From the transmitter, the data will be transmitted one after the one another, as is shown in this figure. And in the UART, it is a hardware component that handles serial communication by converting the parallel data. And here the key features we have to focus is baud rate, data frame, and register. So what is baud rate? Is the data of speed, the speed of the data transmission, and data frame is typically 8 bit, and we have one start bit and one stop bit, and optionally parity flags or parity bit. And registers, we can see in UART we have registers for the main purpose of configuration data and the line control, etc. Interfacing, as you know, interfacing UART we have to concentrate on the sending and receiving the data, and optionally we have to concentrate on the interrupt handling. And here you can see the UART architecture. Yes, we can see you have a transmitter and the receiver. From the transmitter side, we have the register to hold the transmitter data. And this holder data will be having a shifting operation, so that it will be shifted from one after the another. So the next bit can enter into the registers, and we have the control logic, because the data should be transmitted in a sequence, or else on encoding the data the original content may be mismatching. And in between we have a baud rate generator. This baud rate generator is nothing but the speed generator. So how long the speed data has to be transmitted, or how faster the data has to be transmitted, we can customize it. And in the receiver also we have control logic and hold register to hold the data to collect and hold it in some place, and we have the shifting operation so that it can move on to the next bit. And apart from this UART architecture, we have to focus on one thing, because in serial communication we have another types of communication devices like simplex, half duplex, and full duplex. In simplex you can find it here. From transmitter, it will be transmitting in only one direction, from transmitter to receiver. So the device acts as only transmitter or only receiver. Where in the half duplex, the device can act as both transmitter and receiver. So it can transmit and also receive the signal, but not at the same time. And in the full duplex, it acts as the transmitter and receiver, and it can transmit the signal and receive the signal at the same time, where the acknowledgement signal plays a vital role in it. And apart from that, you have UART registers. Yes, we have base registers. Typically, that is 8-bit, and each register has a transmitting, receiving buffer, and interrupt enabling registers, etc., and modem control. And these are mainly used for reading and writing the input data in the output peripherals. And for configuring the UART, the main steps to be focused is baud rate and frame format, and FIFO, that is used for buffering purpose, and the check status signals. And main consideration, yes, we have a baud rate calculation, polling versus interrupts. We have to find out the interrupts where if any other available, and hardware access, as we have to mainly focus on the hardwares which are interfacing with it, error handling, and also modern controls. So in the next lecture series, we will discuss about the UART architecture, that is nothing but the universal asynchronous receiver transmitter, and this is the different type from the UART. So here we have a clock signal, and here also we will have the transmitting and receiving operations. Thank you.